So hi again, everyone. Welcome to DotNext. Welcome to my talk on building an educational game with .NET Core and Unity. Like I explained before, my name is Johnny Hooyberghs. You can find me on Twitter or on GitHub, and I work for a consultancy firm in Belgium, which is called Involved, because basically all of the consultants that work for Involved are involved with their job, involved with their customers. So we like to think of ourselves as being involved. But this is my day job, and during my day job, I do different kinds of projects with different clients, but all of them are .NET and C# related. The last couple of years, I've been doing backend development mostly, architectural work mostly. So you guys know how that works. Sometimes I want to do something different, something fun that is not really possible with my customers. Also, because I'd like to keep busy, I teach at night. So for 10 years now, I teach adult students, and I teach them about .NET and C# development. So what is the game that I've created, and why did I create it? So I already touched on this. So basically, I created this game to teach basic C# knowledge in school. It's a bit of a gamification. So students, even if they are adults, they very much like to learn a programming language, but they like to learn it in a fun way. And for me, an issue with programming languages is if you want to do some cool things, it always gets quite complex very quickly. So if you got a student that is not used to doing programming, you can't do wild and crazy things because they will lose track. So I want to teach basic C# knowledge, but I want to make it fun and a cool experience. But of course, for myself, it was a lot of fun to learn the Unity game engine because I wanted to learn this during my free time. It also gave me an opportunity to play around with the Microsoft compiler platform, or Roslyn. Since Microsoft released their C# and Visual Basic compilers as open source compilers, we can leverage that and use them for our own purposes. It gave me an opportunity to play with the newest version of .NET Core. Actually, I made this project already a couple of years ago when .NET Core 3 was not released yet. But today, the final version is in .NET Core 3, and I'm already working on upgrading it to .NET 5. And then also I wanted to play with Azure DevOps pipelines for myself. I wanted to play with Docker and Kubernetes, and I wanted to do a project that uses test-driven development from the get-go. So my professional projects, I try to do test-driven development, but it's hard if you're working for a huge corporation with large teams. So for my personal projects, I can really go all the way with test-driven development. So this game that I've created, what is it? Well, basically, it's an arena. And for today, because I'm going to demo in a few minutes, I made the arena like a chessboard, but instead of 8 times 8, it will contain 15 times 15 squares. On top of these squares, you can put robots, and those robots can move around this grid. The robots, they will take turns. Every 2 seconds simultaneously. So all the robots on the arena will move at the same time. They can't only move, but they can also attack other robots. And of course, they can see a part of the arena so that they can make decisions based on what they see. Now, the fun part is that each turn is scripted using C#. So a robot will actually execute a piece of code that the player has written in C#, and all of these scripts, so all of the robots that are active on the arena, will run their scripts every 2 seconds. So basically, your script will actually make your robot perform one move, and it will just repeat that every 2 seconds. So you have to make decisions based on the actual game state on the arena. Also, each robot has a limited amount of health and stamina, so it can die, and stamina means it can't move when it's too tired to move. So you need to really do some resource management here, so you don't move around too much if it's not necessary, and keep your health in check. So I've actually, just to give you a context on what it is we're doing, I've created a small demo website. You can visit this link by scanning the QR code or visiting the link directly. You can register yourself as a player. We don't have time for you to actually write the script yourself, so you can just make a selection from a predefined script. You can create your robot, and we can actually see in the next couple of minutes how these robots will perform on the arena. So I've also prepared the demo arena. It looks like this. And well, basically, if you guys and girls make a robot, we should be able to see it appear on the arena. So again, I am a backend developer. I do mostly architectural work. This was my first thing that I did in Unity. Graphically, it's not very high end, but it does what it does. It works, hopefully, and we will see what happens. So let me quickly also create a robot myself. So I'm opening the link myself. I'm creating a robot. I'm going to call it Hunter, and I'm going to deploy it to the arena. There it is. So you can see these robot models. They have some animations. They can do walking around. They can turn around. They can also perform actions like fighting other robots. So actually my Hunter robot that I've created right now is basically seeing the hamster robot. He's trying to get close, and when he's actually close enough, he will try to fight him. So now he made a stupid decision. He turned the wrong way, but now he sees Dan, and he's going to try to hit Dan in the face. See, so now Dan and Hunter are hitting each other in the face, and actually they will probably keep doing this until one of them dies. While Sergi, I saw that Sergi is also throwing some fireballs, so you can also do ranged attacks if you're out of stamina to actually kill each other that way. So now we can see that the two initial robots have actually died, so their body is lying on the floor, and then after 10 seconds the bodies will be cleaned up, because basically when you see a dead body, you don't want to stare at it for more than 10 seconds. So that is basically the game. It looks like this. So students can write some C# code, and they will actually have fun to see the results. So we will come back to this arena a couple of times so that you guys can see what's happening to your robots. So what is the architecture behind this? How did I create this game? Well, it has multiple parts. The first part is the front end, which is of course in Unity. In the past, I tried to do similar things for my students. I wanted to visualize their C# code in other ways. And actually 10 years ago when I started, I was using WinForms to do some drawing in WinForms, and it worked, but it really didn't look so cool. So that's why I decided, I hear that Unity is very easy to work with. I hear that Unity is very powerful. So let's try to do this myself, because I wanted to have a full 3D experience. And it shouldn't be too hard to do for me as a beginner, because I only want a visual experience. I don't want to have interaction. So Unity will just be used to visualize the battle. And also, because I'm using .NET, I can very easily collect the game state every 2 seconds from an HTTP backend. So Unity is not really containing any hard logic. It's just fetching the game state from the backend, and it's basically animating all of its 3D objects to represent that game state, which was a great opportunity for me to learn about Unity. The backend uses .NET Core only, so ASP.NET Core to be exact. It has multiple components. It has a web API, HTTP API for the Unity request. So Unity will just call this HTTP API to get the current game state. It has an MVC ASP.NET Core application for the demo website, the one that you have visited to create your robots. And it has an ASP.NET Core GRPC service for the validation service. So basically, when you create a C# script, the C# script will be validated before it's actually deployed to, let's call it, a production environment. So this validation runs in a separate ASP.NET Core gRPC service, because I wanted to play with gRPC, but I will talk more about that later. And then lastly, I have a worker service, which is basically like a Windows service or a Linux daemon that does continuous processing in the background. And this continuous processing is compiling your C# scripts and also running your C# scripts and then pushing the results from those scripts to the database so that the game state can be updated accordingly. It is very easy today in .NET to compile and run custom C# code by just using the Microsoft Compiler platform. So in short, it's called Roslyn. You just put some C# code into a string, compile that string into a runnable part of code, and then run that code, and that's it. So also very cool that I could learn about Roslyn. The architectural diagram looks something like this. So in the top left-hand side, we have the front end. The front end will talk to the HTTP API, which will talk to the database. Then we have the processor, the continuously running background processor. It will also talk to the database directly. And then we have the web application, MVC web application in the bottom, which also talks to the database directly and talks to a validator service on the left-hand side. So that's it. I decided to make everything talk to the database directly just for performance reasons. I could also make every component go through the HTTP API, but that wasn't really necessary because I'm running everything on the same server, basically. So everything connects to the database directly. Yeah. So now that you have a concept of what my game actually is and what it looks like, so it's C# wars, that's what I called it. So it's a war using C# code. Now that we have this, we can dig deeper into Unity and a bit the backends to see how I really created this. So let's go. So let me find my Unity. So if everything is okay, you should be able to see my screen. You should see the Unity editor. And for me, this was very relaxing to work with because I was used to working with Visual Studio, and it actually looks a bit like Visual Studio. So in the center of the screen, you can see your active scene. So this is basically the file that you have open in Visual Studio. And in Unity, this is called a scene. So a scene is a 3D environment. And inside of this environment, it's like a toolbox, and you can create whatever you want, basically. And on the left-hand side, you can see a hierarchy. This is your current outline of all of your objects in your current scene. So inside of my current scene, there's multiple things. I will dig deep into more detail in just a few minutes, but it's a bit like when you're doing WinForms or WPF development, you also have a document outline. And inside of this document outline, you can see your window. Inside of your window, you can see different panels and buttons and text boxes. This is kind of the same thing. So inside of your scene, there's also multiple objects, and they can also have a hierarchy. And this hierarchy is very visible within this screen. Then on the bottom, in the bottom of Unity, there you can see a project overview. This is like your solution explorer in Visual Studio, containing all of your assets, all of your scripts, all of your code, so that you can easily get to that. And then on the right-hand side is your inspector. This is basically your properties window from Visual Studio. So if you select an object like the directional light here, on the right-hand side, I am actually able to see all of the properties for this light, and I can make adjustments to them. So I started working on this, and I wanted to keep it very simple. So as you could see in my demo, there's just an arena inside of a space, and this space is actually something that I didn't create myself. So if I click on the Unity editor and I zoom out, you can actually see that it's a large sphere. So my arena will actually be located inside of a very large sphere. And this is also something cool about Unity. You can visit the asset store, which is basically like a package manager for assets. And inside of this asset store, you can find all kinds of 3D models and textures and stuff like that. So I was just searching for a spacey skybox. I found a free one, and I just imported this into my project, and I could use it from the get-go. So I didn't really have to do anything fancy to do this. So I used the asset store to fetch for me a skybox that looks like we're in space. I put it in the center of my universe, and if I zoom in, I'm actually inside of the sphere, and it looks like I'm in infinite space. Then the second step was to create the arena. The arena is a large surface, and you need to create like 3D models or meshes, and then import them into Unity. But Unity also has like some primitives, like a sphere or a cube. So I decided to just pick a cube. And this cube is located in the center of the universe. So in the inspector on the right-hand side, you can see the transform. And the transform has a position, a rotation, and a scale. So this cube is actually scaled to 1 by 1 by 1. So 1 in measurement in unities, it can be whatever, like 1 meter or 1 kilometer, it doesn't really matter. It's just 1. So this cube is perfect, 1 by 1 by 1. It's located at position 0, 0, 0 on the X, Y, Z axis. So it's in the middle of the universe, and it's not rotated. So now I actually want this to be stretched out. So I want it to be stretched out so that it forms my arena, basically. So in order to do this, I actually created a method in the backend, and I will show you the backend quickly. So this is a Visual Studio solution containing the backend. It contains my web API. Inside of my web API, there's a couple of controllers, and one of those controllers is called the arena controller. And the arena controller just has one method called getArena. And this will basically provide us with two numbers, the width and the height of the arena, because the arena can be resized. So in configuration, I can resize the arena depending on how many people are playing this game. If only 5 people are playing the game, I will create a smaller arena. So this method will just return the size of that arena. So I need to get those values, and then I need to stretch this cube to be large enough to be my arena with correct width and height. So in Unity, on the left-hand side in the hierarchy, you can actually see that I've created some objects. So there's the directional light, which is like a light, shining light onto my cube. If you don't have light, everything is pitch black, everything is dark. So you always need a light source. It's the same in our real world. We have a sun, and the sun shines light. So this can basically be thought of as, okay, this is maybe the sun that's shining on top of my arena. Then we have the space, which is the sphere containing our skybox. Then we have the camera, which is located here, and it's looking down upon the arena. And then we have the arena itself, which is our cube. So in Unity, I can create scripts, and a script is basically a piece of C# code. So I have created a controller. So I've called my scripts controllers, and it's called the arena controller. So I've configured Unity to use Visual Studio Code. You can configure it to use whatever editor you like. It can be Visual Studio, can be Visual Studio Code, can be Rider, can be something different. So if I double click some code inside of Unity, it will automatically open Visual Studio Code. It will open all of the files inside of a project or a solution, and I can even do some debugging while connected to the Unity editor, which is very cool. So what this controller does, it's using a method called start. So basically, when you have a script in Unity and you load the script, it will call this method start, and I can execute some code. So that's exactly what I want to do. So I'm calling a static class called API client, and on top of this static class is a getArena method. So this will do an HTTP call to my web API. It will get an object back, which is an arena, which is also type arena, containing two properties, width and height. And now I can actually find inside of my scene a game object with the name floor, and I can change the local scale of my floor with the current width and height of my cube, of my arena. So back to Unity. So how can I make sure that this script is actually run when I launch my game? Because now when I press play, just like in Visual Studio, I can press play to launch my game. it will start. You can see the cube is in the middle of the universe. The camera is pointed down on top of the cube, but the cube is not doing anything. In order to make this work, I need to link my script onto one of these game objects, one of these objects. So basically, I'm going to click the arena object, and in the properties window where you can see the transform, and this is actually the transform that I want to use to scale my cube, I'm going to add a component. And I can add a component, I can tell Unity I want to add a script, and I can then search for scripts inside of my controller's namespace, and then there's the arena controller namespace. It has one property, which is cool. Inside of my inspector in Unity, I can see that it has one property called platform height with a description that says the height of the arena platform, which is 0.2. So if I go back to Visual Studio Code, I can see that inside of my script, there is a public float platform height member, and this is 0.2 by default. So I can change this value, I can change it in script, but I can also change it within Unity itself, which is very cool because now I can fiddle around with this value while actually looking at the result. So if I do play again, the script is linked to my arena. It should immediately, when it started, connect to my backend, get the width and height values, and it will stretch my transform. So basically, this game object now has a platform height of 2, and if I open this up, you can see that there's a child object called floor. This is the one that I'm searching inside of my script, and this has a transform scale x15, y 0.2, which is the thickness, and then z also 15. So the scaling is done for me by using the script. So this is basically how Unity works. You create as many game objects as you like inside of your scene, and then you link scripts to them to make them actually do something. So in this case, I'm just doing on start of the script, which means if this game object is loaded into my game, the start method will be called once. It will resize the arena, and I'm done. So next. When you saw the demo itself, you also saw that the camera was slowly rotating around the arena to create some dynamic effect on the actual battle that is going on. So if I click on the camera, I can do the same thing. I can create a script that will automatically transform the camera to rotate around the arena. So inside of my Visual Studio Code, I also have a class called Camera Rotator, and it's the same thing. It also has a property called rotations per minute, so I can easily fiddle around with this value. And now it doesn't have a start method, but it has an update method. So the start method is called one time at the start of your object when it comes to life, basically. The update method is actually a method that's being called by Unity every frame update of your game. So if your game is running 60 frames per second, this method will be called 60 times per second. So if you, for example, want to make an HTTP call within your update method, that would not be a good idea because that method will be called 60 times a second. So this is basically only for rendering purposes. So that's exactly what we want to do with the camera. So the camera needs to slowly rotate around the arena. So I'm going to calculate a Y angle. So basically the camera does not need to rotate around its X or Z axis. It only needs to rotate around its Y angle. And the calculation works like this. It's like 6, which is a constant number, times the rotations per minute that we want to achieve, times time.delta time. And time.delta time is very important here because time.delta time actually tells us how much time is there between the previous frame and this frame. So if we have a frame rate of 60 frames per second, so we know exactly how much time is between the last frame and this frame, and then we can use that into our calculations for rotating. Because if we don't take into consideration the frame time, when your computer has a lot of trouble running your scene and it's not achieving, for example, 60 frames per second, but it's dropping lower, your animation will also start to go slower. And you don't want your animation speed to be directly dependent on your frame rate. So that's why we need to take this into consideration. So if you have a low frame rate, each skip the camera would take, so the camera would skip from one place to another. If we have a low frame rate, the skips will be larger. If we have a very fast frame rate, the skips will be much smaller. So back to Unity. So the same thing here. I can click the camera game object. I can add a component, select a script, select the camera rotator, and you can see immediately, because I was still running, immediately my camera starts rotating. And now I can have this cool property, this cool value, and I can easily change this if I want to fiddle around, if I want to make it perfect. So maybe this is a little bit too slow, I don't know. Let's try 10. 10 is way too fast, so let's slow it down again, maybe 2 or 3. So you can immediately see the effects of this script by just changing the properties at runtime. So if I stop, this is something that you need to look out for. If you make changes to your scene while running your game, those changes are not saved. But you actually need to do it while you are not running. So I'm going to do it again, make it 2. And then I can start it again, and now these changes will actually be saved into my project. So now the camera is slowly rotating around the arena, which is exactly what I wanted. Also, a nice feature of Unity is my scene has 2 different ways of looking at it. I have the game, the running game, but I also have the scene itself. The scene where I can do my design, where I can drag objects around. And actually, I can see my game running inside of this scene. I can select the camera, hopefully if I'm like this, and I can see the values immediately changing. I can also see a preview. I can zoom in, I can select the arena, and I can check the inspector to see all of the running properties. One thing I want to tell you about the camera is actually that these game objects, they really help you doing movements, because the movement of the camera is basically very hard to do. It needs to run in a circle around the arena. So if you want to do this by changing the transform of the camera, it's going to be hard, because you can see that the position of the camera is 0 on the x-axis, 5 on the y-axis, and -10 on the z-axis. So in order to make it rotate, I need to rotate it, but I also need to change its position, which is very hard to calculate. So what I did is actually I created a game object, which is a cube. It has the same size as the cube you can see here in the middle, but it's not the same thing. It's an empty game object. It doesn't contain any physical objects. It's in the center of the universe, and it's 1 by 1 by 1. And then as a child, I have the camera. So the camera is a child of this camera game object. So I have 2 objects called camera, but the deepest one, so the child, is the actual camera, and the underscore camera is basically the container for that camera. So the camera is located in reference to its container. And now I can make it myself easy, and my script is linked. The camera rotator is linked to my container game object and not my camera itself. So the only thing I'm doing right now is I'm rotating the container. And by rotating the container, the camera is linked to that container and will automatically rotate with that in reference to that container. So that's why my code is actually quite simple. I just need to rotate around the Y angle. I don't need to do any movement of the camera. It will automatically rotate the arena, which is very cool. Okay, so that's the camera and that's the arena. Something that I forgot to tell you, this is all happening within my scene, and you can do whatever with that scene what you'd like. If you create a real game, it can have multiple scenes, and for like a classic old school game, this can, for example, be a level. A scene can correspond to a level. Like if you do Super Mario, for example, like the side-scrolling game Super Mario, you can actually make your player walk around in your scene until it reaches the end. Then you can unload that scene, load a next scene, a different scene, which contains your next level, basically. But inside of this game, we only have one scene because it just needs to display the arena. Okay, so the next step would be to actually put the robots on top of the arena. So in order to do that, I'm going to use something that is called a prefab. So in Unity, you have objects and different kinds of assets. So for example, you have a mesh, which is a 3D object. You have a texture, which is the visualization that you want to put on your meshes. You also have materials. Materials will help you on defining how light will reflect or being absorbed by your object. So for example, wood and glass will behave very differently, so that's material. But you also have prefabs. And a prefab is like a blueprint. It's basically, you create a prefab containing whatever you want as a blueprint, and then you can create easily multiple instances of that prefab. So a robot, for example, we are using a prefab for this because we can have multiple robots on the arena depending on how many robots are active at this moment. So the prefab basically is the same as your scene, but in smaller regards. So the prefab here is a robot. It also has a hierarchy, and it contains multiple elements. It has a body, it has a hand on the left-hand side, a hand on the right-hand side, it has a head, and so on. So you can create this prefab, and then you can create instances of that. This robot is also something that I downloaded from the Unity store. So I didn't create it myself. I just found like a robot that has some integrated animations. I thought, okay, I can use this, so I'm not going to create this myself. So if I go to my scene, click my arena game object, I now have an arena controller. This arena controller will resize the arena to its correct size, and I'm going to add a second script to that. So you can create as many scripts and link as many scripts to your game objects that you want. And I'm going to select the bots controller. And the bots controller will actually make sure that the robots are created when they need to be created and that they are destroyed when they die. It has a few properties, like, for example, the refresh rate. So the refresh rate will be 2 seconds. So every 2 seconds, the game will update its current bots. And then we have some other properties. So for example, the first one is the bot prefab. So this script needs to know what your prefab is because it will create instances of that prefab. So my prefab is here in the bottom in my project explorer. I will just drag it on top of this property, and now my script knows that this prefab is actually the bot prefab, and it can create instances for that. And I have some other prefabs also, like the name tag. The name tag is like the name floating on the top of your robot containing the name of the player. There's the health tag, which contains your current health, and there's the stamina tag containing your current stamina. So I'm just dragging them on top of the script, and now the script knows that it needs to create those robots. So if I press play again, the robot should be created, but it's not doing anything. So the robots are created. There's actually 2 robots inside of the arena right now, but they're created on top of each other. They're perfectly centered inside of my universe, so they are not doing anything. The reason for that is because my prefab is not doing anything. It doesn't have a script attached to it. So I have 2 scripts, basically. I have the bots controller script, which is a controller for multiple bots, and I will show you very quickly what that looks like. So my bots controller. It also has a start method, and it will actually invoke a method repeatedly, which means every 2 seconds it will call this method, and this method will do get bots on my HTTP backend API. So it will get the current game state, so which bots are active. It will clean all the bots that have been killed. It will do a for each loop on top of the bots that it just received from the backend, and basically it has a dictionary of robots that are already created, so that I can see, okay, do I need to create a new robot or just update an existing one? This line of code will instantiate a new prefab. It will make it a child of the arena. It will get a reference to the controller, the bot controller, which we did not yet couple. So there's no link between bot controller and the actual bot itself. So we will do that in just a minute. And then it will instantiate the 3 tags. So the name tag, the health tag, and the stamina tag. And then if the robot already exists, it only needs to update the controller so that the controller can do whatever it needs to do to put it in the correct position and to perform its animations. So now the bot controller is the one that actually controls a single bot. And this has a start method to configure its animations. And it also has an update method. And this update method will also be called every frame update. So every frame update, we will check if the bot is not available, something went wrong, we just return. If the robot is confused, so if you make an error, a runtime error inside of your code, there will be a red exclamation mark on top of your robot so that you can see that something went wrong. So I'm basically instantiating a prefab which contains the exclamation mark. I'm setting it as a child of the robot's head so that it floats on top of its head, changing its position to be on top of its head. And that's it. If your robot is not confused, I will destroy the exclamation mark. So the exclamation mark will be gone again. And then we just go through all of the different things that can happen. So basically, I calculate if your robot is moving around. So if it has a different position on the arena, I will calculate based on vectors where it needs to go. I will change the position of the robot, and I will do an animation which is walking. So the robot that I downloaded from the Unity Asset Store has integrated animations that I can just run by calling the run animation method. If it's changing orientation, so if it's facing a different direction, I'm changing the rotation of the transform, so not the position, and I'm running the animation that has the turn animation. And then if it's dying, I can animate it dying, really falling to the floor. I'm destroying the name tag, health tag, and stamina tag because we don't need them when it's died. It just needs to be a body on the floor, nothing else. If it's attacking using melee, I'm just doing this animation. If it's using a ranged attack, I'm doing a ranged attack animation. But I'm also instantiating, again, based on a prefab, a ranged attack, which is a fireball, basically. And this fireball has its separate controller, which has a fire method, and it will basically animate the fireball going through the air using its own controller. So I've made controllers so that each controller can actually make every single object do whatever it needs to do, so that it's separated from each other. So again, I can do this very easy. I can just click my bot prefab. I can add a component to that, and I can just add the bot controller script to that, and then I can fill in the properties. So the speed can be 1, the rotation speed can be 2. I need to link the head of this prefab. So the controller needs to know what is the head of the prefab. So for that to work, I'm going to open the prefab. I'm going to select the head object, and I'm going to drag that into this head property. So now the controller knows where the head is. And then it also needs an error prefab, which is this red exclamation mark, so that it can create an instance of that when necessary. And then the ranged attack prefab, which is the fireball, so that it can make an instance of that. So if I go back to my scene, and my arena instantiates a new robot, linked to that robot will also be the bot controller script. So for each robot that's being instantiated, it will also automatically create an instance of the controller, and the controller will be linked to that specific robot controlling it. So now you can see that the two robots are not created on top of each other. They are placed correctly, and they are performing their animations at the same time. So these seems to be two robots that use the same script, and they're just turning around because they basically don't have any stamina left or something. So that's it. So this was very quickly on how I did this game in Unity. So for me, again, I really like this because it's quite simple if you want to do simple things. Obviously, when you create very complex games in Unity, it's going to be much harder. And I will talk a bit more about Unity in just a few minutes. So for now, let's get back to my slides. So we have 15 minutes left before Q&A, so I'm just going to dig a bit deeper into what I learned as a non-Unity developer. So obviously I learned Unity, and for me now Unity is something that I can use whenever I need to display something cool. I can create something in Unity in a couple of hours, basically, and that's exactly what I'm doing right now. So it's not only a thing to play with; it can also be a professional thing. For example, I work for Involved, the company Involved, and every year we do like a competition in Belgium. We call this competition Hack the Future, and it's for basically students. They can enter this competition and they can write code, and at the end of the competition they can win something. Each year, there's a theme in this competition. And in 2018, the theme was the artifact. And the artifact was like something that came from space, and the students needed to write some code to unlock the secrets of this artifact. And for me, this is so cool. I am writing or I'm organizing the specific .NET challenge for this competition, and I wanted to create like a dashboard for the players or the students to see how they are actually doing their coding. So I thought, okay, let's do this in Unity. But before I was thinking about Unity, I actually used SketchUp, the tool from Google in the past, to create like a physical version of this artifact sphere. So I was drawing this, and why was I drawing this? Because I wanted to recreate the artifact myself. So I went to my basement, I bought some wood, I used SketchUp to calculate all of the angles to know how I needed to create this. So I created a physical version of this artifact, and then when I finished with the physical version, which had LED lights controlled by a Raspberry Pi, I could put it inside of the room. Students would create solutions to problems, and then the lights would change color based on what they were doing. But I also created a virtual version of this, and the virtual version, I used Unity. So very cool. I could just import the same thing that I created in SketchUp. I could import it inside of Unity, and it just worked. So I created like my physical proof of concept in SketchUp, which I used for actually making the physical object. I just imported it inside of Unity, and I could work with that in Unity. Just to show you very quickly, I'm going to open the Unity solution for that, which is this one. So this is the Hack the Future dashboard for the .NET challenge. And this is something that I made in a couple of hours, thanks to Unity being so simple. So this is my SketchUp object. Each side of the sphere or the artifact corresponds to a specific challenge, and it lights up in a different color based on whatever challenge is doing. Here I could also work a little bit with interaction, because now I can actually drag my mouse around and I can drag the artifact around. Again, if you need something professionally, you want to create like a 3D environment to display something to a customer, Unity is so easy to use and so powerful. So I would certainly recommend using Unity for such things. What did I also learn? Unity is C#. So for me, as a long-time C# developer, this was just perfect. I can use my current knowledge. I can use whatever I know in C#. I can use my generic knowledge from C#. I can use await async, whatever. It just works. I can also use external libraries if I want, because I'm basically writing C# and .NET code. I can use external libraries from NuGet or from wherever to basically use. And this is what I did with the API backend communication. So I'm not writing the API communication myself. I'm just using a NuGet package. And in this case, I used REST Sharp because it's very easy to use. And in this use case, it doesn't need to be any more complex. So I tried to do NuGet in Unity, but that doesn't really work quite well. So what I did was I first used Unity, and then I copied the physical DLL to my assets, and then I removed the NuGet package again, and then it worked. So now I have just a physical DLL inside of my assets, and I'm just referencing this one, but it works perfectly. The only thing you need to think about is that Unity does not use .NET Framework or .NET Core. Unity uses Mono. So Mono is the open source runtime for .NET. It's been there for a very long time already, and Unity is using this one. So it's actually not compatible with .NET Core. So if you have libraries that are specifically .NET Core, you will not be able to use them in Unity, because Unity uses the Mono runtime. You can, however, use .NET Standard, because .NET Standard is compatible with the .NET Framework, with .NET Core, but also with Mono. So if you have libraries that are written in .NET Standard, then you can use them in Unity without an issue. So why is Unity using the Mono runtime? Well, because it needs to compile your game to multiple platforms. Unity supports multiple platforms, for example, PC, Windows, Mac, mobile, Android, iOS. It even has support for Xbox, PlayStation. It has support for web, so it can create a web application from your game. So in order to make this possible, it actually uses the mono runtime because the mono runtime is already compatible with lots of these platforms. But some platforms don't have support with mono, and that's why Unity also provides a second option to compile, and they have like something they called IL2CPP, which is a translator, and that will translate your compiled .NET code, which is intermediate language. That's why it says IL, and it will transpile that into C++. And if it's C++, they can compile it to native code, and that native code can run on even more platforms. Like, for example, smart TVs. You can even compile your game for a smart TV, and then it will use C++ native. I also learned the modular workflow based on game objects. So you can create your scene, and inside of your scene, you can put your game objects the way you like to make them work. For me, it was a bit hard because I'm mostly a backend developer, and I'm not used to this kind of editor workflow. So I needed some time to get used to dragging around stuff in the Unity editor. But in the end, I managed to be able to do it. One thing that I think was hard for me in the beginning is Unity gives you a lot of flexibility with this. The modular workflow based on game objects basically gives you an opportunity to do whatever you want. You can create the hierarchy however you want. You can link your scripts to your game objects however you want. And this gives you a lot of flexibility. But it also makes it very hard in the beginning if you are a beginner, because you don't really know what the best practices are. You're just searching on the internet, how do I need to link this script to a game object? And people have different opinions about that. So you basically need to read a lot about this and form your own opinions, what makes it easy for you or your team to work with. Unity also has a wide range of support for 3D models. Like I told you, I can just create something in SketchUp because I'm actually, SketchUp is very easy to use for me because I did a lot of AutoCAD in the past, and it's a bit the same for me, but then simpler. And I can just import that in Unity and use it. And then something I want to finish off with for Unity is it also has community support for different kinds of patterns, programming patterns. And I am a huge fan of dependency injection. In all of my projects, I have been using dependency injection for many years. And Unity also has support for this by using community plugins like ADIC or Extenject, for example. Let me quickly show you this. Actually, a couple of weeks ago, I made an update to my game. So this is the first version. Actually, I made a second version that doesn't link scripts to game objects because, like I told you, I am not used to this whole editor workflow. I like to do everything from code. I'm a hardcore backend developer. I just want to be in code and only code. So that's why I decided to use dependency injection with a framework called ADIC. And I changed my hierarchy a little bit. So I created a root game object, and inside of my root game object, there's another game object that is called game loop, my space, camera, and arena. So it looks a bit the same, but it's configured differently. And now my camera does not have any scripts linked to it. My arena does not have any scripts to it linked to it, and my robot prefab shouldn't have any scripts linked to it. This should be removed. Like this. And actually, I created a root game object, and the root game object contains everything. So the root game object contains the link to what are all the prefabs, what are all the objects that I need to work with, and now I've centralized my workflow basically all in the same game object. This is my root for my scene, and here is where I configure my entire scene. So I don't need to look around for different kinds of objects and what do I need to link with which object. I just do it in one place. So for me, this is easier because it helps me to not make mistakes. Everything is in one single place, and I can easily see if there are any mistakes by just looking at this. And also the root object will configure the whole dependency injection chain for me. So if I go to my scripts and then my game root, and I open this in Visual Studio Code, it uses the ADIC container, so it adds a container and it groups different kinds of things. So these are just regular classes from C#, an API client and a game state based on an interface. And then we have our Unity game objects. So here I can just bind a game object to my floor specifically, and I'm going to name it. So I'm going to give it a key called floor, the same with the floor renderer. Here I'm going to link my scripts to my prefabs. So I'm not doing it in the editor manually. I'm just doing it here using dependency injection. I say, okay, my bot controller needs to be linked to my bot prefab. My name tag controller needs to be linked to my name tag prefab. Because I like to do everything in code, like I told you before. Here it's the same thing, some specific named things that I'm also binding in dependency injection, and then my controllers to actual objects inside of my scene. So now this, together with what you saw in Unity, is everything that is needed to link my scripts to my game objects. And if you now look at a game object itself, you can see that it has properties. So this one has a property called game state. So instead of the controller making a call to the API client itself, now I'm always going through a game state object. And the game state is basically one object that contains the current game state. So it's like a singleton. And these are being injected automatically by my injection framework. So I have the inject attribute on top, and automatically this will get a value when an instance of the bots controller is created. It's the same for all of these properties. Also, before I was using dependency injection, I noticed that a lot of my controllers were actually talking to each other. So my bot controller needed to place my robot in a specific location on top of my arena, but it really didn't know the location of the arena, so it needed to talk to the arena controller to calculate where the actual location was, which I don't like. I don't like all of my objects talking to each other. I want them to be separated from each other, and dependency injection helped me to reach that goal. If you go online and you read about this, there's some mixed feelings about using dependency injection in Unity. A lot of people that create games, they're not a huge fan of doing dependency injection. But again, I'm using this for my specific workflows. And for me, this works best. So basically, you make the decision by yourself. And yeah, see what happens and learn from that. I of course also learned that Unity is platform independent, so I already compiled to a web also, which works perfectly, which is cool. And then specifically on .NET Core, I didn't really talk about this, and I don't have the time to go any deeper into this, but I'm actually using Docker containers for all of this because it's extremely easy for me to deploy. I can deploy this in Azure by just using a pipeline from Azure DevOps, but I can also deploy it to my local server here at home. So now it's running on my local server here at home. And the deployment is basically the same thing because I'm doing a Docker container. And right now I'm also deploying this whole thing into Azure Kubernetes service. So it's working, but I still need to do some tweaking on that, which is, again, also easy because I'm just using these Docker containers. So for me, this was the first project that I really did with containerization, and it's been wonderful. Also, a cool side effect on this containerization is that I had some issues with the scripts. When I play this game with people that are not used to writing C#, they make a lot of mistakes. If you use Roslyn to run a C# script and it has an infinite loop, you have an issue because it keeps running and it actually slows down your process, and it's in memory, and it's very hard to kill it. And that's why I created the validator service. So the validator service will actually run a couple of scenarios through your script to make sure that you don't have any infinite loops, and that you don't create any other mistakes. So this validator service, it actually over time, it will be dirtied up by multiple scripts that are running indefinitely. And thanks to Docker containers and Kubernetes, I can just create a deployment that says, okay, if this container reaches 100 megabytes in memory usage, just kill it and spin it up again, which will just destroy everything, spin up a new instance, and it's clean again. So it's very easy for me to keep my memory usage down, my CPU usage down. I can just clean up my containers and run new ones when that's necessary. So very cool. I also learned that .NET Core is more performant than the .NET Framework, because my first version of this game was actually in .NET Framework and not even in .NET Core, and it's a lot better, really. I think in the .NET Framework it took like 100 or 200 milliseconds to run 10 scripts, and now it's in milliseconds. It's like 1 millisecond, 5 milliseconds, something like that. I also learned about gRPC. Actually, I wanted to use gRPC for Unity to backend communication, but Unity still doesn't have production gRPC support. It only has experimental gRCP support. So I couldn't get it stable enough, but I have to retry because it's been a couple of months already. So I'm using that for server-to-server communication. So my web MVC demo application will actually talk to my validator using gRPC. It's faster because it has a smaller payload, it's binary in size, and it's not using JSON or XML, and I can even do streaming with that. I also learned about Roslyn, so using the Microsoft compiler platform is very easy. I just put some C# code in a string. I throw that against Microsoft compiler platform, it will compile it for me, and I can just run it. Of course, infinite loops are not easy to detect, and it was hard for me to keep my memory usage low, but I did some modifications, and now it's working fine. And for some reason, scripts cannot be canceled. So when I run a script, I get a task as a result, and I was not able to actually kill these tasks. The only thing that you can do is use a cancellation token and cancel the cancellation token. But if the script itself is running code from my players are not using cancellation tokens, basically. So if they are not responding to a cancellation token being canceled, I can't cancel the script. What I tried to do was, okay, find the thread that is running behind the task from whatever thread pool the task is fetching the thread from, and killing that thread, but I couldn't get it stable enough to actually kill it. So that was an issue that I still had with Roslyn. So I'm very quickly going to show you what this looks like in Visual Studio. So as I told you before, I have the web API, but I also have the processing middleware. It has the processor. This has a middleware class, and this has a bot-script compiler class. So this bot-script compiler is the only code that I'm using to compile my C# and my string C# into an actual runnable script. So the return type is script runner. It lives in the namespace Microsoft Code Analysis Scripting from Roslyn. And here I can do, where is it? Here, C#script.create. So C#script.create is a static method that will create a script runner based on a decoded script, which is a string. And then there's a couple of things. There's options, so you can provide options. And because as you could see, the script itself is just a piece of C# script. It doesn't have a namespace. It doesn't have a class. It can have a class, but it doesn't need to. So it's basically running in a vacuum. So there's nothing surrounding it. So I can just add references to the assembly for system core, the dynamic assembly, the C# script assembly. So I need to add my references manually in the script options. I also need to add my usings on top of my script. So I'm using system.link, system.collections, system.collections.generic, whatever people are using when they are writing scripts. And then lastly, I also provide a globals class, which is not obligatory. You don't need to do this. You can do this. And this provides a context. So if I show you what the C# script looks like, let me quickly show you. So this is what a C# script looks like. But as I said before, it doesn't have a namespace or a class. It's just an empty script. So what I do is I create a class that surrounds your script, and this class has some specific methods defined. So if you are calling a method called load from memory or turn left or walk forward, these are actually methods that exist in the class that this code is running inside. And that's the script globals class. That's this class. So this class will basically run your script as if it is a method inside of this class, and it has access to all of the methods. It has access to walk forward, turn left, turn right, and so on. So this is how my scripts basically work. So with that, my hour is over, and I would like to thank you. And if you have any questions, I'm happy to answer them for you.
So, Johnny, thank you very much for your interesting talk. Yeah, we have some questions for you. So, actually, first is this very amateur question about starting to work with Unity. So, what is the experience of someone who just puts his hands on Unity first? What is the biggest issues? So, you've told a bit that you had, as a backend developer, to get used to this objects and their hierarchy, but what are other like technical problems? How do you spend your first 2 days with Unity? Is there a good documentation? Because when I searched something, there was a lot of YouTube videos that were named something like "Learn C# in 1 day," etc.
Yeah. As I told before, I think Unity itself is simple to understand because it looks a lot like Visual Studio or Rider or whatever development environment that we are used to working with. So that shouldn't really be an issue. The thing that I also liked very much is that basically you can create something and you can immediately press the play button on top and see the results. So for me, the first 2 days were a lot of trial and error. So you just write a very small script, you link it to a game object to make it move around, and you just Google, okay, how do I need to make something move around? And you find some examples, you just copy paste those examples into your script. And you can immediately see what's happening. So you don't have a compiling, you don't need time to compile, you don't need time, just press play and immediately see the effect. So
is there such thing as debugging there?
What was your question?
Is there such thing as debugging?
Exactly.
So
I didn't show you, but I can try to very quickly show you. If you use Visual Studio or Visual Studio Code, you can actually install a plugin. So in Visual Studio, it's a plugin from Unity itself called the Unity Editor Support or something. And then you can basically inside of Visual Studio press play on the top and then attach to an existing process, and you can attach it to the Unity editor itself, and then it will actually debug your C# code. And from Visual Studio Code, it's also a plugin, and then I can do run inside of the Unity editor right here. So if I press play inside of my Visual Studio Code, it actually links automatically to an instance of the Unity editor. And then inside of the Unity editor, when you press play on the top here, and it runs your script, it will automatically hit your breakpoints. The Unity editor will completely freeze because it's hitting your breakpoint, and you can just look at your variables. You can look at whatever inside of here. So you can just put breakpoints here. I can't show you that exactly now because I actually have 3 editors open in Unity, and I don't have the option to select which editor I'm using the debug for. So this is just selecting the first Unity editor, which is running something different, and I didn't want to figure it out. But if you have one editor in Unity open, it will automatically link to that editor, and you're good to go. So exactly, this is very helpful. Also, you can do debug.writeline inside of your code if you want that, and the debug.writeline will actually show up in your console inside of Unity. So inside of Unity, in the bottom, you also have a console, and you can write messages to this console if that helps you while you are creating your game. But then again, to come back to your first question, because so many people are doing Unity, there are a lot of different opinions about a lot of things. So for me, the flexibility that Unity provides makes it a little bit harder to get used to it, because sometimes you have to make your own decisions. It's very hard to see online, okay, which is the best practice, because different people have different best practices. For me, that is the biggest. Yeah, that's the biggest issue for me. And that's why my first approach, I was doing whatever people were telling on the internet to do. So creating the game objects, linking my scripts to all different kinds of game objects. And I didn't like that, because then my whole workflow is basically spread around my entire scene, and I don't like that. So that's why I refactored everything, and now I've put everything inside of a single game object using dependency injection, and everything else will come from that automatically. But then again, if you look online for hints about dependency injections, there is a lot of people in the Unity world that say this is complete bullshit. You shouldn't do dependency injection in Unity because it already has something similar inside by using the game objects. But yeah, again, this is what I feel most comfortable with.
Okay. So another thing that you were talking about is this update method that is called like 60 times, for example, yes. 60 times per second. So yes. I'm not sure I understand very well. So this frame rate, is it something that is variable, or is it something that you can set?
No, it is variable by default, and actually I had an issue with that, but I will start with explaining the basics. So if you run a game and it's not limited, it will actually run as many frames as it can. So the more powerful your PC is, the more frames it will run. Why? Okay. Because the more frames it will run, the more smooth your animation will look like. If you have 120 frames per second, it will be extremely smooth. If you only have 10 frames per second, you will see the stutter. You will see each frame individually. By default, your game should, I think, run 60 frames per second. Actually, I had the issue with that, and that hopefully explains your question. So inside of my bots...
My question is actually about performance, because if you're counting something, not even something difficult, but for example, you tested it on a smaller frame rate and it worked okay, and then you run the same thing on a more powerful on another machine, and it has a higher frame rate, and it starts to stutter, like you say.
Yeah, so that's why the update method should basically only do rendering things. So it should just look at, okay, what is the current frame rate? What do I need to do? So in my case, it's just moving objects around. That really doesn't take a lot of calculation from your CPU, so that's just fine. If you're doing like calculations, if you make a complex game where enemies really have artificial intelligence and they need to make decisions based on difficult calculations, that is something you shouldn't do in your update method. You should do that in a separate method that runs continuously in the background, and that will make sure to communicate its results to your whatever controller script that you have, and your controller script can then use that result and just draw that result. In Unity, you have support for await async, so you can run methods in the background that do calculation by using async await. But you can also do something like what's it called again? I forgot. There's actually in Unity there's something like it's not this, but it looks like this. It's like run background and then a method name. So then it will run this method in a background process, in a background thread. I forgot the name of the method, but I used this before, and now I removed it again because now I'm using await async. So again, calculations don't need to be in your update method. Your update method should only draw your scene or draw your object or move your object, whatever.
Yeah. I see. Okay, and another maybe a quick question. So what is interesting is how you do the validation, because as far as I understand, you let the users, the players, download the scripts. So just write whatever code they want, and it will be run by this Roslyn compiler. So that sounds like a very dangerous thing to do. So like you give infinite control to the users. Therefore, as far as I understand, you do have this validation service, but how do you make the checks for something like the script trying to take infinite memory, etc.? So
Well,
inside of this validation?
Your question has two parts. The first part is, how do you make sure that they can't do whatever they want? Well, basically, the compiler itself tells the limits. So you do add reference, like you do in Visual Studio. You add a reference to a separate library, and I'm actually telling that these are the only libraries that you can use. So you can't just hack into my code. And why you can't hack into my code is basically because I have two separate projects. I have my processor project and my scripting process project. And my processor project is actually compiling and running your scripts, and my scripting process is the one that contains all of the code that is necessary to make your script be able to run. And you are only allowed access inside of the scripting, because I am adding a reference from your script to the scripting library, so you can't get out of this library. So that is how I keep the scripts in control. But of course, you can still use memory access if you want. And then secondly, the validator service is this one. It's at this moment in time, it's very simple. It actually calls this helper. So let me quickly, it's probably here. It actually it compiles your script, and it will also use a stopwatch. So if you create an insanely large script and it takes too long of a time to compile it, I will reject it. Because of course, if your script needs to be compiled and it takes 1 hour to compile, it's going to put down my entire backend, so I don't want that. So I'm timing that. And then second of all, I'm running your script inside of a task, and I'm just trying it out with like a arena size 10 times 10. I'm creating some bots inside of this arena, some demo bots basically, and then I'm building the entire environment. And then I'm running your script. And then I'm also timing using a stopwatch how long it takes to run your script. If you have an infinite loop, this task will actually run out. It will time out, and I can send you a script validation message that says your script did not finish in a timely fashion. So that's how I block these scripts. I am actually busy right now by using advanced features of Roslyn to actually look at the code, because using Roslyn, you not only have the code in a string, you also have the complete hierarchy of your code. So I can really do line by line. I can loop through your code and I can see if you made any mistakes. But that is very hard to do. That needs a lot of code to actually make a route throughout all of the code that you've written. So I'm still working on that.
Okay, so I think we will end with this part of the questions, and we can move soon to the discussion zone. So thank you for your talk very much. Hi, Kate.
Okay, you're welcome.